Okay, these are some of the notes for day 2 of 8.6 on adding and subtracting rational expressions. You know, anytime you add fractions, which is what rational expressions are, fractions, you have to have a common denominator. So today we are going to work on adding things that already have a common denominator and then move into adding things that do not have a common denominator. So starting on number 15, I have a squared over a squared minus 36 plus 6a over a squared minus 36. They have a common denominator already, so I add the numerator. That gives me a squared plus 6a over a squared minus 36. And now, before I finish the problem, I have to, in order to do that, I have to see if I have any factors that I can cancel on the top and the bottom. So of course I have to factor both the numerator and the denominator. The numerator factors to a times a plus 6, and the denominator is a difference of squares, which factors to a plus 6 times a minus 6. Now, as I'm doing these problems, I'm not going to spend time showing you how I get to the factors. So if you're having trouble keeping up or seeing where my factors come from, just put the video on pause, go do your factoring process, and then come back and see if you're getting the same thing that I am. Okay, so now I'm looking at the top and bottom, seeing if I have anything that I can cancel, and of course I do. The a plus 6's cancel out, and I'm left with, as a final answer, a over a minus 6. The a in the numerator and denominator there cannot be canceled out because the a in the numerator is a factor, but the a in the denominator is part of a binomial. It's one of the terms in a binomial. It's not a factor because it has a plus or a minus sign next to it, so it can't be canceled out, and a over a minus 6 is my final answer for that. Okay, for number 16, once again, we already have a common denominator. It's b squared minus 4. So I simply add my numerators. That means I add 2b plus b squared over my common denominator, b squared minus 4. Now, of course, I have to factor both numerator and denominator so that I can see if I have anything that'll cancel. What's alike in the numerator is b, and that leaves me 2 plus b when I factor out that GCF. The denominator is a difference of squares, so that factors to b plus 2 times b minus 2, and so 2 plus b and b plus 2 are common factors and can be canceled out. Now, they aren't in the same order, but remember, addition is commutative. I can write them in either order. Both signs are the same, so it really is the same factor. What I'm left with is b over b minus 2. And again, those b's will not cancel out because one is a factor and one is part of a binomial, which means it can't be canceled out. Okay, problem 17, as you can see, does not already have a common denominator, so we have to find one. I'm looking at just the numerical part of my denominator. 24 factors to 6 times 4. Now that's not prime factored, of course. 18 factors to 6 times 3. Since they both have a 6 in it and I'm looking for my least common denominator, I know I'm going to use 6, and then 4 and 3 don't have anything in common, so I also multiply those. 6 times 4 is 24 times 3 is 72. And now for the variable part, when the base is the same, you take the higher of the exponents, so 72b squared is going to be my LCD. Now, if you can't remember how to get to that 6 times 4 times 3, remember you can always take the larger of your two denominators and start multiplying it. If it is not a multiple of the other number, like 24 is not a multiple of 18, you can say 24 didn't work, so let's try 24 times 2, which is 48, and see if that's a multiple of 18. Well, 48 is not divisible by 18, so it isn't. Multiply 24 times 3, and that gives you 72. Divide 72 by 18 to see if it divides evenly. It does, and there is the numerical part of my least common denominator. That's another perhaps easier way to find your common denominator. So now that I know what my common denominator is, I have to figure out what I multiply each of my denominators by to have that common denominator of 72b squared. Well, 24 divides into 72 3 times, so I have to multiply the top and bottom by 3, and b divides into b squared b times, so I'm multiplying the top and bottom by 3b. Now remember, 3b over 3b is 1, so that's not changing the value of my fraction, it's just giving me the right denominator. Okay, now 18 divides into 72 how many times? and that's going to be, what do you think? 4 times. 18 goes into 72 4 times, so I need to multiply the top and the bottom by 4. B squared I already have. That was the variable part of my common denominator, so I don't need to multiply anything there. So now I multiply 3b times 5a, which gives me 15ab, over my common denominator of 72b squared, plus 11a times 4 is 44a, over 18b squared times 4 is 72b squared. And now this is just like the problems we finished a minute ago. I already have a common denominator. I add my numerators over that. 15ab plus 44a divided by 72b squared. And there are no factors in common to both of the numerators and the denominator, so that's my final answer. Because 72 has a 3 in it and 15 has a 3 in it does not mean I can cancel those out, because remember, it would have to be found in both terms in the numerator and in the denominator. So once again, that 15ab plus 44a divided by 72b squared is my final answer. Okay, for problem number 18, again, before I can add these, I have to have a common denominator. 28 factors to 7 times 4. Again, that's not prime factored. 21 factors to 7 times 3. I chose the 7s as what I took out because it's the same in both of them. Now the 4 and the 3 don't have anything in common, so I multiply 7 times 4 times 3 and get 84. My variable part of that is going to be z cubed because I take the higher powered exponent. So 84 z cubed is my LCD. So I need to look at 28 and say, how does that divide into 84? Well, it divides 3 times. So I'm going to multiply by 3 over 3, which of course equals 1. I don't need to multiply my variable because I already have z cubed. And now I say 21 divides into 84 4 times, so I multiply the top and the bottom by 4. Again, that equals 1, so I'm not changing the value. And then I have z in the denominator, not z cubed, so I need to multiply the top and the bottom by z squared in order to have my full least common denominator. So now 3 times 3y is 9y, plus 5x times 4z squared is 20x z squared over my already common denominator of 84 z cubed, which is what I get when I multiply 3 by 28 z cubed, and also what I get when I multiply 21z by 4z squared. So now, again, I just want to double check whether or not I have anything in common that I can factor out and cancel, and there isn't anything because there is a 3 in both 9 and 84, but not in 20. There is a 4 in both 20 and 84, but not in 9, so that is my final answer. Nothing else can be done to further reduce or simplify that.